So as you can see, I have two small functions. Both functions are doing the same job. Function one, which is log number one, I take a num here as a parameter, and then I'm using the for loop to iterate from 0 until this number is included. And then I'm just logging the number. Then the second function, I'm doing the same here. I'm checking if num is 0, then I'm logging the num, and then I'm returning, I'm stopping my function. I'm calling my function inside my function, as you can see, with num minus 1, because I want to log num minus 1, minus 2 until it becomes 0 and 0. I will log the 0, then I will stop calling my function here. That's recursion. Console.logging num. Now, these both functions are doing the same job. This one is logging from 0 until num. Here, it's logging from num until 0. But basically, they are doing the same job. Okay? You're with me or not?
Yes.
Good. Now, if I want to determine which function here is more performance than another function, so the first factor I need to put into account, which is the time, right? So how can I calculate the time consumed by or needed by function one, log number one, and log number two? To calculate the time, all I have to do just console.time. And console.time here, it will calculate how much time in millisecond that's needed for this function. And of course, here you can pass any string you want to, because I'm using a for loop in the function one, or I can just name it, for example, log num1, like that. So I know which function is I'm calling. Now I will call my function here, which is log num1 with 10,000. I can make it even 100,000 if I want to. So you need to put a large number. A large number, why? Because a large number, it will give you more time. So if the number is big, this function will need a little bit more time. This one a little bit more time. Like that, I can determine which function is a little bit faster. Now here, I need to end it with console.endTime, as you can see. And I'll pass the same comment exactly like that here. It will log now how much time needed for this function in millisecond. I need to do the same for function 2, so I will just console.time log num2, and I will call the function 2 with the same number. Remember, they must be with the same number, because I'm trying to compare the time consumed by both functions. If it's not the same time, same number I am passing here, you cannot compare them. It doesn't make sense, right? If I want to compare two persons, I need to have a measure. And the measure here, both functions doing the same job. So I need to pass the same number with both and then calculate the time. Now, if I run this script here using Node, or if I use normal JavaScript, where I create index.html and run it, click on it. Of course, it will now, as you can see, it will log a lot of stuff, a lot of number, as you can see. That's not what I want to. I don't want to show the number. I just need, I'm interested only in the time. That's why I'm gonna comment these logs, because I'm not interested in them. I don't want to see them. After I comment this log, now I'm gonna run my script again. And as you can see, log num1, which is a function, this function here, it took 1.05 millisecond. And the second function here, which we are using recursion, is taking 0.76 or 0.7 actually millisecond. So which one do you think is more faster comparing to the others? Yeah.
Log num2.
Of course, as you can see, so num2 is faster comparing to num1. Why? Because this one is taking 0.7, here is taking 1 millisecond. Here 0.7, so it's really normal that this one is faster comparing to this one. So that's how we determine if one function here is faster than another function. Now, the behavior of both functions is the same exactly. This one is logging number from 0 until num. Here, it's the same idea. It's logging from num until 0. So it's the same job they are doing. They are doing exactly the same job. But this one is faster comparing to this one. Well, that should be simple. So to calculate let's say, the speed or the time needed to this function, both function, to be executed, or to see which function is a little bit more faster comparing to the other, I will put both of them under the same condition, and that's why I'm calling log num1 with 10,000. I'm calling num2 with 10,000, and after that, of course, in the beginning, before I need to use console.time, and here I need to write some comment to know which function I am calling. So the comment I'm writing here, it will be here, and after that, it will give me the time. And after I'm calling my functions, then I say console.timeInt. So when I say time, it will start calculating the time needed. When I say console.timeInt, it will end the time. And here it will automatically take the end time minus it from the beginning of the time, and it will give me the result, as you can see, in milliseconds. Is the idea clear? Yes, no?
Yes.
For everyone?
Yes, but Samir, I have a question. So every time we need to test our function, what function is faster, or it will come with experience?
It's come from experience. Oh, well, it come from experience, and also here, but now you don't have experience, right? So you do not have experience. So how can we find a tool? Even if you are the most expert person on some function, I don't know if this function is faster sometimes than this one. For loop, normally for loop sometimes is faster than recursion, but in some algorithm, recursion is faster than for loop. So I don't know. In general, for loop, in general, the general idea from experience, I'm telling you for loop is faster. But as you can see, when I calculate them, that's not the case. You get the point there, yeah. So no one knows for 100%. You need a tool to use it.
Yes, but is it something just good to know, or we will use it in a daily job?
No, you don't use it in daily job, but something really good to know.
Okay, got it. Thank you.
Of course, now what I'm going to do here now, I'm using 10,000, I'm going to use million. And you may tell me why you are using million, because like that, both of them will take more time, and like that, I will have a better idea about the performance of both. If no one here, what's it? Maximum? So because I'm using a million here, as you can see, recursion. So I have an error, maximum call stack size, because I told you the call stack is the maximum size for the call stack. It can call 16,000 function, but here I'm using a million. And here I cannot do that. So what I can do here, I can stick with my number, which is 100,000, and try to do the same. And let's see. Same idea, I cannot actually even use 100. So let me use 10,000. Or maybe what I can use here, actually, instead of 10,000, I can use 16,000. As long as both the number are the same, there is no problem. 16,000, voila. And now here, let's try again and see. Still, I have a problem here. So let's stick with 10,000 and 10,000. And save it and run it again. You need to do this process multiple times, not just one time. So as you can see now, if I do it again, actually the time needed for function 1 is 0.3. And here for recursion, as you can see, is 0.7. So what's happening here is function 1 actually it's faster than function 2. So that's what I told you. In general, for loop is faster than recursion in most of the time, except in some algorithm. And that's what gave him here. Now, this measure is not 100% accurate, so you need to repeat it multiple times, not just one time. So I need to do it multiple times, and then after that, now I have tried second time, as this one is a little bit faster. Let's try it again. And now here, as you can see, this one is faster. Let's try it with another number here. Let's try it just with 1,000 and see. Let's do it with 1,000 and see the result. Okay, if I try it with 1,000, as you can see, indeed, again, this one here, the recursion is a bit faster. Actually, it's a lot faster comparing to this one here, because this one takes 0.07 milliseconds, this one taking 0.2 milliseconds. Is the idea clear? Yes, no? Hello?
Yes.
Okay, so now we know, at least we know one tool to calculate the approximate time for function to be executed. But actually, it's not only the time or the speed of the function determines that, it's also how much memory it consumes. So how could I calculate the memory? Now, to calculate the memory, I told you your website need to be alive. So if my website is alive, let's just go here, it doesn't matter. And here we have something called performance, and here I can record some stuff here. But as I will teach you this one at the end of separation of concern, because we will have our website, and then we can determine if our website is okay or not, if there is any memory leak. So for now, we're not gonna use it. We're gonna use another tool here. Okay, so what is the other tool? The other tool here to calculate the memory, we can use node. Now in node here, we have something called process.memory usage. So I can say const memory before what was the first function name? It was log num1, right? Log num1. So I can calculate the memory before I call the first function, which is called memory before log num1. How can I call the memory? Well, the method here is process dot memory usage, which is the method, and here this method return me a property which is called heap used. So it gives me the size of the heap is being used. And now I can call my function, which is log num1. I'm gonna remove this one, okay? Or maybe I can keep them, it's fine. I'm gonna call my function again, and then I'm gonna again use this method to calculate the memory after I'm calling num1. And here what I can do, I can take this memory after I call num1 and minus it from the memory before I call it, and like that, I will know how much memory this function is consuming. And here I have to look memory used by log num1. Here it will be memory after log num1 minus memory before log num2, and it's in bytes. Is the idea clear? Yes, no? So to calculate the memory in node, of course, that's not in JavaScript, it's just in node. We call process. So process here, it's an object. And in process, we have memory usage. Memory usage is a method on it. When I call it, it will return me an object, and I can access the heap used. As you know, before I told you function, object, and array, they are stored in the, where they are stored?
Heap memory.
In the heap. And that's the reason why I'm using the heap used. So what I need to do, I need to call this method here to calculate the heap used, the size of the heap used, before I call my functions. And I'm going to call my functions, and I'm going to use it again to calculate the heap used after I call my functions. Then I will take this value, minus it from the first value, and it will give me the size in bytes. I'll do the same for the second function. As you can see, I'm going to call it voila, voila. And now here, let's run our code and see what will happen. So click, voila. So as you can see here, what is giving me here? It's telling me log num1. So it's telling me num1 is consume 1720 bytes. But num2 or log num2 is consume only 214 bytes. So which one consume more memory? Which one consume more memory? Is it log num1 or log num2?
Number one.
Of course, number one. So as you can see, the number one, log number one is consuming more memory. Actually, if I calculated 240 and 240 and 240, I think it's maybe more than 7 times or maybe than 8 times. Because here 240, if I say 240 plus 240 plus 240 plus 240, I think it's giving me around 1,000, 240, 240. I think 7 times or 8 times this function. Here, this function take less memory comparing to the first function, which is called log num1 or log number one. Now, depending on these two factors, I can determine which function is more performance. And by performance, again, I mean it's taking less time and it takes less memory. And it's obvious from my result here, as you can see, log num2 it's faster, okay? And also it takes less memory. That means when I'm gonna use these two, I can decide from now that this one here, it will be a better option comparing to this one. Is the idea clear? Yes, no? For the others,
Samir,
yes.
log number one, when you call the function, you have 1,000.
Mm-hmm.
And if we put a bigger number, it cannot affect the memory.
Of course
The
that-
memory will be the same.
No, if you increase the number of the times, then memory will change. So let's try to use 10,000 here. 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 And let's try to calculate our script again. Let's click. Now, as you can see, actually they are taking the same here. They give me the same. They shouldn't be the same actually, but as you can see, they give me the same. So from here, I can see, yeah, the time is a little bit close. This one 0.7 milliseconds, this one 0.8, but this one is taking less memory. They shouldn't be the same actually. If I try again, oh, they even give me again and again and again the same. Actually, they shouldn't be the same because when I call the function more and more and more, I'm making more, the call stack, it will be bigger, and the memory is taken, it will be a little bit bigger. Is the idea clear?
Yes.
Yeah, but small note for you, a small note for you. Now for calculating the time, as we see now, it's not really, I need to use it multiple times. So it's not just one time to give me the real time. So it's not absolute time, it's approximate time. But it helped me to determine which function is faster than the other. Now, when it comes to memory here, remember, I'm not using only the memory used by this function. So memory usage here, heap used, I'm not just calculating the memory used only by this function. I'm calculating the total memory used by node. So here, when I say heap used, it's not only the memory is taken by the function here only. No, it's just calculates the total heap, whatever inside the heap. So this one here, as you can see, it's an approximate number. It's not 100% number because calculating the memory really in JavaScript is not that easy. It's quite complex. And here, as I told you, this heap use is not only the used by the function here. It's the total memory used by the whole node process. Is the idea clear? Yes.
Yes.
Good. So as you can see, now, if I have multiple solutions, I can at least now determine a little bit which solution it could be more performance than the other solution. So if, as you can see here, if this one here, I can see log num2 is taking less time, and I see it's taking less memory, and I try to, of course, I need to do it multiple times, not just one time, multiple times, and I see all the time the result is approximately the same. So I will prefer to use function 2 over function 1. Is the idea clear? Teniendo?
Yes, yes.
Good. Now,
Yeah.
what I can do also now, let's see if ChatGPT is smart or not. I'm going to copy this one. After I, of course, I use the tools here. I can go to my ChatGPT. And in ChatGPT, I can ask the question, which function is faster and take less memory? Or both of them, I can just say which one is more performance. Okay, performance means is the speed and the memory taken. So I can say which function is more performance, and here, and why. And why. Of course, ChatGPT here, it will, not all the time, it will give me 100%, but let's see. So here, why, what I'm interested in is why. I'm not interested in this one here. In terms of performance, as you can see, the for loop is likely to be more performance. I told you in general, that's the idea. Indeed, for loop is more performance than recursion, but not all the time. May encounter stack overflow. Stack overflow, as you saw now, when I call it with million, is telling me that I reach the maximum call stack, because my call stack here in JavaScript, I can call maximum 16,000 function. I cannot use it with larger number. So that's what they are telling you. But here, ChatGPT is telling me most probably using a for loop, it will be more performance. But from my experiment here, I found actually recursion in this example is more performance comparing to the for loop. So ChatGPT is not always smart. Is the idea clear? Yes, no?
Yes.
That's simply how we determine approximately which function is more performance than the other. Of course, in real life, we don't do that. As I told you, it's good to know, of course, but in real life, we need to have our website. After that, when our website is alive, everything is alive, I can go here into DevTools and I have something called performance. which I don't have it. Where is it? Performance, voila. And here in performance, we can record, I will click on this one, and then I will reload my website. And then here I can stop. And as you can see, it will give me a graph here, and here it will tell me how much millisecond here, how much time is needed to load the script, the JavaScript, how much time needed to render my website, how much time needed to load the website, how much time need for the system to be operated, and stuff like that. And from this graph, after that, I will teach you how to see if there is any memory leak or not. You don't have to worry about what's memory leak for now, but later on, when we finish separation of consent, I'm gonna teach you. Is the idea clear? Yes?
Yes.
Perfect. I'm gonna stop the recording then. And voila.